That
practice good.
That light feels so stupid.
Okay guys, other questions other than 25? Because we're going to be adding on to this today, so we want to make sure that you guys, that this is okay before we move on to like kind of the next topic. So 29. You're here early today. Oh. We're learning about the other two trig functions today. So we've learned about tangent, and then we'll learn about that sine and cosine. So makes it a little bit tougher once they add the other ones in, because you have to decide which one to use. So still not bad though. So 13, they make a mistake, and we have to determine what their mistake is. So they tell us the tangent of D is 18 over 82. So they make a mistake. It says describe the error in the statement, correct the statement if possible, otherwise write not possible. So it's possible, like if it's not something we can fix. So we talk about angle D here. I'm going to label everything based off of angle D. So this is my opposite side, this is my adjacent, and then my hypotenuse. Remember, the tangent is the opposite over the adjacent. So they just have the sides in the wrong spot, and they're using the hypotenuse. So we don't want to use that side at all with tangent. Today we're going to learn when we use that. So the tangent of D is going to be opposite over adjacent, so 80 over 18. So that was their mistake. They didn't have a whole lot right going on there. All right, going to 25. So 25 is one of the ones where they're not telling us the side we probably want. They're telling us kind of the other side. Oh, and they asked for the perimeter too. So this is 31, this is 6. They want the perimeter, so that's the distance around the shape. So I'm going to label what I know here. So this is my opposite, my hypotenuse, and my adjacent. Now if you guys recall, yesterday Ellen pointed out, if we're trying to figure out the adjacent side here, it might be easier just to switch our perspective and use the other angle. We're going to talk about what happens when we can't do that today. So instead of using it the label the way we are, I'm going to erase that. So we can find this angle. If this is 31 and this is 90, I know this one has to be 59. Because then they would add up to 180. So now the opposite side is my x. And then here's my adjacent. And then my hypotenuse I don't know, nor do they ask me anything about it quite yet. So we're going to do tangent of 59. And again, the reason why we're doing that is because we don't like that x in the denominator. And again, we're going to have to deal with that today. We'll talk about that. So x over 6. Opposite over adjacent. I'm going to multiply each side by 6 to get my value for x. So 6 times the tangent of 59, I find out x is like 9.98, so very close to 10. That's my x value. Now, they want to know the perimeter, so that means we also have to find this hypotenuse, or the c. Let's change that to c. So I'm going to do a squared plus b squared equals c squared to find that c. So I have 36 plus 9.9 squared, which is like 99.7. Add that to 36, get like 135.7 is c squared. Take the square root of that, and I get like 11.6 for my c. And then to find my perimeter, I just add up all the edges. It's totally understandable if that one was tougher. We didn't do one that asked you for the perimeter. Guys, stop talking, please. So then let's look at 29. So 29 wants us to find y and z, round to the nearest tenth. So 29 has two triangles, which sometimes makes it a little bit tricky here, but hopefully that actually will help in this case. So we know this is 45. This is 82. This is y. This is 28. And this is z. So in this case, hopefully you guys noticed that this triangle over here is a 45, 45, 90. So that means y is also going to be 82 degrees. Or 82, sorry. Used to something that large being an angle versus a side. So y is 82. Now, if you totally forgot the special right triangles, you could have used Pythagorean theorem. You could use trig to figure that out, but I would just use the fact that I know those are both the legs. So now I'm at the point where this is 82, this is my z, and this is 28. So I need to find z. Opposite over adjacent would mean z's in the denominator. So again, if you don't like z being in the denominator, you can figure this one out to be 62. Again, we're going to have to deal with that anyway, but just because we did talk about it yesterday. So here's my opposite side. Here's my adjacent, if I'm using that 62 degrees. So tangent of 62 equals z over 82. So to multiply each side by 82. So 82 times tangent of 62. And we get like 152 for our z. All right, so I will get you guys your new notes today. So now we're talking about those other two trig functions, sine and cosine. Again, if you guys, you want your calculator today because of the fact that these sine, cosine, tangent are really hard to do in your head or by hand. Okay, just a reminder, please leave backpacks in the locker. Thank you. Tuesday. question asking you guys to find the value of x. Those of you guys online, I'm using a new recording app, so let me know if it's not working as well. I used to use Google Meets and it just sent me an email, and now it's taking hours for them to send me an email with the video, so trying something different. All right, so in our warm-up here, we have our angle 15. Label everything based off of that. So opposite, here would be my hypotenuse, and so this is my adjacent, and tangent is opposite over adjacent. So then in order to figure out the tangent, I'm going to multiply by 52. And that'll allow me to find that other side length. And that'll be 13.9. So, yeah, today we're learning those other two trig ratios, which are sine and cosine. We have notes today and tomorrow, and then I think we'll review for 2 days again, and that means we'll be testing next Tuesday. So, heads up on that. If you guys are still thinking about retaking our most recent test, I would really suggest trying to get that taken care of this week. Then you don't have to worry about that for next week. Or if you're not feeling ready for the test, please let me know. We can always meet on Friday during that virtual time. Especially your class, I was pretty, I didn't need to meet with a ton of people, so I had time to meet with other students if we needed to, where some of my classes are a little bit worse in terms of missing work. So you guys are pretty solid that way. We're not have to worry about a lot of missing work for you. So, for our trig, now we're talking about sine, cosine, and tangent. So again, this is the full name, and then this is the nickname. So sin, cos, and tan is what shows up in your calculator. Now, there's an acronym that is used to help us know sine, cosine, and tangent and memorize them. Sounds like I'm speaking in another language. It's SO, CA, TOA. So it's just a way to remember the different trig ratios. So if you talk to someone that's taken trig before and you say SOHCAHTOA to them, they'll know exactly what you're talking about because it's just a way to remember the different trig ratios. So in this triangle, we're talking about angle A, notice. So I'm going to label everything based off of angle A. Now, like Ellen mentioned yesterday, she asked about angle C. We never use the right angle as our angle that we're taking the sine, cosine, or tangent of. So we'll always work with one of the other two angles. So A is across from BC, so this is going to be my opposite side. Here's my hypotenuse, and then here's my adjacent. So what do you think the letters SOHCAHTOA are for? Does anyone notice what you think that would mean? Like, why would that be helpful? We learned TOA yesterday. What do you think that stands for? Yeah.
The tangent, opposite, and adjacent? Yeah,
so they're telling you what goes in which part of the ratio. So the T is tangent, so that's telling me it's opposite over adjacent. So it's kind of like a little, like, just memory tool. And it, like, happens to be a little bit catchy in terms of, like, when you say it, like, it kind of, like, almost sounds like it, like, rhymes or whatever. It kind of has a rhythm to it. SOHCAHTOA. So opposite and adjacent is telling me that ratio. So what do you think SO means? Opposite over hypotenuse. And the S is for sine. And then the CA is our cosine, so that's adjacent over hypotenuse. and remember things. Now, eventually you might not even have to write that down, or maybe on every single test at the top of it, you're gonna write SOHCAHTOA down to remember that like kind of acronym that goes with it. So that allows us to set up all these different ratios. Now the reason why this is helpful is because yesterday we learned about tangent. We were totally leaving the hypotenuse out of it. Now we could find the hypotenuse using Pythagorean theorem, but if the hypotenuse is what we're looking for and we want to skip right to that, then we're going to use sine or cosine. Or if like we just have some different information, if they give us the hypotenuse, we might want to use sine or cosine. So we'll talk about those ratios today. So, in this case, they want us to find the ratios in simplest form. And this is similar to what we did yesterday. It's just now we're doing sine, cosine, and tangent. So, they're starting with n. So, angle n is where I'm starting from. So, label that triangle using that angle n. So label it, you label your opposite, your adjacent, your hypotenuse. And we're going to set up those ratios. Give you guys a minute, I need to check for our activity. So hopefully you guys were able to label this triangle based off of n. So I start with my opposite side would be this 9, my hypotenuse, and then our adjacent. So again, with our sine, cosine, and tangent, until you guys kind of get the hang of it, or even when you do have the hang of it, we have SOHCAHTOA. Now tangent we're good with, opposite over adjacent. So opposite over adjacent is going to be 9 over 12, which would just be 3/4. If you guys like, those numbers sound familiar from yesterday, and that's because this is a 3, 4, 5 right triangle. And I mentioned I use those all the time because they're really, it's an easy one to use because the numbers are nice. So then our sine, what's our ratio going to be? What over what? What you guys get? What did you get for your ratio for sine? What's your fraction? Yeah, Dawson?
3 over 5.
3 over 5, so you did 9 over 15, which becomes 3 over 5. Very good. How about your cosine? So adjacent over hypotenuse, 12 over 15, which would be 4 over 5. Now, like we did yesterday, then we change the perspective. Then I say, what about happens if now we're doing L? So now L is going to be our angle. And you have to change the labels. So now the opposite side now is no longer the adjacent. This is now the opposite side. This is now the adjacent. The hypotenuse sticks. So see if you guys can set up your sine, cosine, and tangent there. adjacent sides. So again, when we talk about our SOHCAHTOA, the opposite and adjacent sides flip. So now this time, opposite over adjacent is going to be 12 over 9, which, like I said, we did this that same fraction last time. So that's going to be 4 over 3. But now for the sine and cosine, the O and A switch, but the H's stay the same. So now the opposite side is 12 over 15. So 4 over 5. And this one's going to be, 3 over 5, which I shouldn't have wrote as 9 over 15. And so this was similar to the first problems in your homework from yesterday, kind of just getting these ratios set up. Do you understand where these numbers come from and kind of how to evaluate with them? Or like how to set up those ratios. So we'll move down to the bottom where we actually do some examples involving these trig functions. Now, they're not going to tell you which trig function to use. So that's what makes today a little bit tougher. I don't think much is tougher about this other than not knowing which trig function to use. And I'll show you guys how to figure that out. So, for example 2, they want us to find x, obviously. So I'm going to label everything based off the angle I know. So here's my 25-degree angle. Where's my opposite side? That's my x. What's the hypotenuse? 10. And then the other side is my adjacent, but they don't really ask me anything about that, so I don't really need the adjacent. It's not necessary in this case. So we have to decide which trig function to use. So here are my options. And I want to use the one that's going to tell me what the opposite is and use what I know, and I know the hypotenuse. So which trig function do I want to use that involves the opposite and the hypotenuse? So has opposite and hypotenuse in its formula, so that's the one we want to use. So you can determine that based off of what you're looking for and what you have. It's kind of like, I don't know, I feel like this happens all the time at our house is we're all looking for the wrong screwdriver, like the kids are trying to open something and we have to know what tool we need, and so we're looking for the right thing. It's kind of the same idea here. So we have that's sine of what angle? What's our angle? 25 degrees equals O over H. O over H. What's my O? X over H, which is 10. The sine function doesn't work any differently as long as you have the button on your calculator. Now instead of using tangent, you're just going to use sine instead. So in order to get that x alone, what are we going to do? Multiply by 10. So you're going to do 10 times the sine of 25, which again probably seems like you're just punching in numbers and getting hocus pocus answer, and that's what we're supposed to get here. So it's not something you shouldn't have to know what sine of 25 is in your head. That's okay. Use your calculator. Now you should look to make sure the answer makes somewhat of sense. I got 4.226, 4.2-ish for our x. Now to look at my drawing, does that make sense? Yeah, that sounds fine. If it was 42, I hope I'd look at that and be that doesn't seem right. Okay, questions there? All right, so example 3 is drawn a little bit weird. It's kind of hard to tell, but this 73 is supposed to be in that little corner down there, just a large angle. So that's this angle is 73. So the opposite side in this case is the one that's not labeled. So it's that's the side I don't really care about at this point. My hypotenuse is across from my right angle, which is the 6. And then that means this x is my adjacent. Which trig function do we want to use? We want to use cosine this time because we want to know the adjacent, we know the hypotenuse, and the CAH, the CAH, has adjacent and hypotenuse in it. So we have cosine of our angle, which is 73, equals A over H, which is x over 6. Alright, so now we have to multiply by 6. So again, cosine works exactly the same way, just make sure you use the right trig function. It's looking for the cosine. And my x value ends up being about like 1.75, which again makes sense because of our x is a pretty little side there. Alright, so if you guys want to flip the page over, I'm going to show you guys what happens when we kind of get a problem like we were talking about yesterday, where our variable's in the denominator, and we don't really know what to do with it. We should be able to actually solve that and figure it out. So if you guys can flip the page over, we'll do example 4, and then we'll do a Kahoot once I find the one I was going to use. I don't know what I saved it as, so I'll have to find it. So when we have our angle here, we have our 15-degree angle. Here's my opposite side, and then here's my hypotenuse. My adjacent, they don't mention, nor do I care anything about it. So which trig function are we going to use?
Sin.
Yep, so we're going to use the SO or sin or sine, whatever you want to call it. So sine of 15 equals, so it's so, that means the opposite has to come first, so 16 over x. So we saw one like this last time, and Ellen had suggested it was really good intuitively that she said, let's switch what angle we're looking at. If we switch the angle, it's still going to be the hypotenuse, so it's still going to be in the denominator. So we have to figure it out this time. We have to learn how to get that x out of the denominator. So we can't kind of sidestep this one. We're going to have to actually kind of face the music here. So I'm going to show you guys something that might help you kind of figure out what to do. If I write it that way, does that give you a clue? Yeah, we can do, remember cross multiplying with proportions? So we can cross multiply this. Now you just have to be really careful and really organized with this. The way I like to write it, just so it's clear and it's not confusing or less confusing, I'm going to do x times the sine of 15 as being multiplied. Otherwise it looks like sine of 15x, and to me that's confusing. So I'm doing x times the sine of 15. Now, and that equals 1 times 16. Now, if x is being multiplied by the sine of 15, how do I undo that? Divide. So what we can do is we can divide by the sine of 15. This moves as 1. Sine of 15 is its own number. So I'm going to do 16 divided by the sine of 15. I want you guys to practice putting this in your calculator. Make sure you guys get the answer we're looking for. So 16 divided by the sine of 15 should work out okay. It ends up being 61.8. Is that what you guys got? No?
I'm gonna be square roots and stuff.
Oh gosh, why is there square root? Oh,
You just have to hit like.
yeah, then you have to hit that little thing.
This one.
Yeah. And then, but you have to do 16 divided by that.
Yeah, how do you get that, like, you said that you do the answer thing the previous
Well, so
one too.
you yeah, so you could do 16 divided by, or that's how I would do it, and then just hit the yeah, so 61.8. If you guys are getting some crazy square roots, anytime, like you might get some, like, because this is kind of a weird property, this one, that can show up. The little, like, there's a little arrow button that looks like this. If you hit that, it'll tell you what the decimal is. So if you're having like some crazy square roots, did you guys get 61.82? Is anyone having issues with the calculator? You get it to work? You guys get it? Yeah. I know on the cell phone it's a little bit finicky because you kind of have to do things a little bit opposite. Okay? So we're going to pause right now. You're going to probably want whiteboard or scratch paper to set up our ratios. We're going to do a Kahoot on the SOHCAHTOA stuff. So you want your notes out. You want your calculator handy. I'm going to turn the board off for a second. I would stick with English, okay? Once we're experts at trig in English, then you can flip over.
Oh. That's
Sorry, there's no fun questions here. I couldn't find the one I had, so. We need music. Like Christmas.
Let's change the time. No.
Everybody in?
Yeah.
Okay, thank you for everybody who's not.
Tree.
One is signed. Only about 5 seconds left.
Perfección en la ola.
Sine is the opposite over the hypotenuse, so.
Estás en la escuela.
Let's go.
Todos que veces no lo
Well, I suppose the question doesn't show up in Spanish on your screen. I was thinking it would change that, but you guys don't see the question on your screen. Yeah, if you need us to move, if something's like my computer's in your way.
Distintos detrás de
Yep, so toe over A. Oh, Abby, sad.
I read the wrong
Hey,
one.
look at that. Let's go. Let's go.
Alright, here we go.
Okay, so these you actually have to solve. They give you 2 minutes. So you're finding X. If you guys need help getting it set up, let me know. Determine which trig function to use.
Where's the on button? There it is. There.
What?
I just found the calculator.
Are you kidding me?
Let's go, guys.
Oh, sad.
I'm
And it's like, what makes a triangle cycle like listen to you? I don't know. If anyone needs help, sub a minute.
Michael started.
I'm sorry. Well, okay, so I told Tyler, Tyler's like, why do you want to play? I'm like, well, my parents said I need to do something with my evenings. And then I asked him, because then he's like, okay, you're on the team then. And then went home and like, can I play basketball? And then like, I don't know. I'm like,
Yeah, typically, if that's what you're looking for, one of those 2 sides, yeah.
I don't know.
When you're looking for the hypotenuse, that's when it's
I'm
covered.
on the team, so.
Good work, you guys.
Nice.
so how do I go back if they say no? I'm like, yeah, I'm pretty sure I can say no.
Wait, is that the same one?
No.
Yes, it
Oh.
is.
No, the last one's 27.
Both the same.
No.
What? The freak. If that's why did not do this earlier. Oh, that's why.
Good work, you guys. So,
I'm insane.
so again, yeah, I thought it looked like the same question, but it's opposite over adjacent. So tangent of 25 equals x over 10, so we're just multiplying each side by 10. And again, your answer should make sense. Like if this is a 25-degree angle and this side is opposite it should be the smallest side. So kind of use a little bit of reasoning as well. So sometimes you eliminate an answer that's not a good choice.
70 puntos detrás I'm cracked.
Determine which trig function you need.
Luke, give me a couple more weeks and I'm gonna be done.
I would know.
It's not this week, I can't play
You're
this.
already starting.
I can't play this week.
You can't play?
This week.
You have to have so many days of practice in it.
That's weird. Just have to sleep your bed tonight.
Yeah, I'm not. I will.
Okay guys, so this one becomes cosine because it's adjacent over hypotenuse. So you're using the cosine of 39 as x over 7. Assuming whoever ran in fast may have just gotten them wrong for that reason. But. Well, this is one of the tougher ones. It's similar to the example we just did.
No. It's pretty tough. It's pretty tough.
Imagine, write something down. Oh my gosh.
Guys, who already answered? Come on.
We still have like a minute and a half, so don't let the time scare you.
Wait, just know what we did over here.
Wait.
This is fun.
Let me know if you need some help.
8. Yup. No, you don't. You don't have it. Come
Didn't have to write anything down.
on. Yes, you did.
Doesn't get started. I think.
We got it. Crap.
You guys, that was pretty good, you guys. Holy cow. So, on this one, this is the opposite over the hypotenuse. So hopefully you use sine. If you didn't use sine, you would have gotten it wrong. 8 over x. Now this is the kind we just did. So you have to set up as a proportion, and you cross multiply. You basically end up dividing these two. X times the sine of 46 will equal 8, and I'll divide by the sine of 46 from each side. Because x will equal 8 divided by the sine of 46. So definitely the tougher ones when that variable is in the denominator. You guys are doing really well. I feel like they draw the same picture every time we just change the number.
What? I love the game.
Oh, it's okay, happen. See, try jumping in. Try weird.
What place were you
You were
First.
third.
in? You were not the first
I
time.
think you were third.
Third.
That's
Michael, you aren't in third. That's me.
Oh, that's a deal. Oh, really? Good people.
Don't say.
Michael, why did you say that? Come on.
Don't worry, Michael, you're in the situation.
So what place were you really?
Yeah.
Not the greatest.
I mean,
It's just, you're so much quieter than him. I like forget, like you need to be loud. Like, I mean, you can't forget that.
that. You can't
He's
forget
so
that.
nice and quiet. Oh, look, he went up.
Yeah, because I was on second.
All right.
You're lucky.
Okay, guys, another little tougher one. Careful there. There's a couple of different ways you can solve this one. You have plenty of time.
Nope, got it at the end.
Her name is Grace. She was in the hospital.
Nice.
Oh.
But she's so fine. She's not even 7 pounds yet. Okay, so guys, let's talk about this one. This was a little bit rough. So, what trig function did you use?
I understand.
You should use tangent because it's opposite over adjacent. Now, you could have used Ellen's method where she switched what angle she used. I don't know if you did that here, but we can do tangent of 46 equals 7 over x. So this is the kind that when the x is in the denominator, you have to use the proportions, or you have to switch your angle. So x times the tangent of 46 equals 7. So I'm going to divide by the tangent of 46. So that'll give me my x value.
It's your fault.
Whoa, big lead change there. I'll do it. Yeah, I mean that's the thing with these problems. If you type in the wrong thing, you almost don't notice your answer could be wrong. So kind of double check work, or maybe, hopefully you'll figure it out. Find the missing side here. Sorry.
I got 11 hours. I'm not hours back.
So guys, this one, you have to use the tangent, so it's opposite over adjacent, and this is just a normal one, where this is the opposite here. So it's going to be tangent of 72 equals x over 20, and I have to multiply each side by 20.
I was pretty tired. The basketball practice made my feet bleed.
Lead?
Yeah. Yeah.
Holy crap. You guys did well. I mean, the top 3 to be perfect were the top 4 and 5 perfect.
Wow. Wow.
Good job, guys.
Sammy and Gabriel. So top 5, come on up.
That's amazing.
Over there. They're like, oh, that's nice of you. They're letting me go first.
I knew I should cheat on you guys.
I remember how he growls at us. Hey, it's a lot of pressure.
All right, time. Participation trophies. Everyone up? Would you like to come grab a after you guys can? There's some random other things in there.
I was hoping while I was engaged by 4 points. And then I was, meeting former team on Tyler and we also got her on.
easy to find. Okay, so we'll go back to notes here, finish up our last, I guess there's quite a few examples still here. We'll finish up the rest of these. You guys really, I mean, I'm really impressed by how well you guys are doing on this, and like I said, I think trig is really doable and it makes a lot of sense. So hopefully it continues to be that way, you know, over, kind of just get yourself bent out of shape about it for no reason. So I think it's doable for all you guys. You're doing well so far. So example 5, now this time they want you to find both x and y. So right now, we only know one side and one angle, but they want you to find both x and y. And we're actually going to do a lot of this tomorrow, is finding all the different parts of the triangle. So I would start with the angle 55 degrees, because that's the angle we know. We'll label everything based off of that. So opposite, hypotenuse, and then adjacent. Now this one, we kind of have our choice of what we want to use. There's probably one I would say not to use, one I'd probably say I probably wouldn't use, there's probably one I would say that that's the one I would choose to use. What do you think? So there's kind of like three choices here. One's a really bad choice, one's partially bad, and the other one is going to be the good one. What do you think? Any thoughts?
The really bad one would be opposite over hypotenuse.
Very good. So we definitely don't want to use sine. Opposite over hypotenuse, we'd have two unknowns. So let's throw that one out altogether. That one's not even in the running here.
The really good one would be opposite over adjacent.
Yeah, so the one we really like is we like when the adjacent's in the denominator. It just makes it a little bit easier. One less step. I think those are the more doable ones. So like Luke said, I would probably use opposite over adjacent. That's the really good one that I would choose to use. Now, you could use cosine, it would work. It's a little bit extra work, but it's not bad. So tangent of our 55-degree angle equals opposite over adjacent. And so to get our x alone, we're going to multiply by 8. And that'll give us our x value. So x is like 11.4 is what I got. Now once I know x, how can I find y? Yeah?
Cos over cosine?
So you could use either sine or cosine you could use to find our h now. Does anyone have another way we could find? There's another way other than sine or cosine. Yeah. Yeah, you could choose to use trig because now you know trig and you might like trig a lot or be just thinking of that. Otherwise, don't forget, we still have a squared plus b squared equals c squared as an option. So we can use that. I think that's a little bit easier, but it's really up to whatever your comfort level is. So I can use this now to find my hypotenuse. Now, if you're like, I know trig now, I'm going to use trig all the time, it's fine. But a squared plus b squared equals c squared works just fine. So 11.4 squared plus 8 squared equals c squared, which would be our y. Now when I do that, I usually leave whatever was in my calculator before that 11.4 really big over here. I leave that and just square it. Plus 8 squared. And I get like, these two together, I get like 194.53. So I'm going to take the square root of that. And again, I do square root of the answer. And I got like 13.9, like almost 14 for my hypotenuse. So depending on your rounding, you should get something around 13.9. All right, questions there? see if you guys can do that for example 6. So that example 6 is really similar. See if you guys can figure out how to like find x and y there. So for example 6, get it all labeled to begin with. I'm going to start by labeling it if you're working there. I labeled everything as opposite, hypotenuse, adjacent. Which trig function did you guys choose to use? Like so sin or cos probably would be my choice because we know the hypotenuse. So since we know that, we want to use that in some way. So either sine or cosine would be best. So since I heard sine first, I'm going to do that. So I'm going to do so first. So sine of 21 equals O over H, so x over 22. So in order to get that x alone, we're going to multiply by 22. So we're going to find out our x. Now, had you found y first, that's fine. So we get like 7.88 for x. So just like on the last problem, we can choose to either do sine, or we can use cosine, or we can do Pythagorean theorem. Do you guys have a preference? What do you think? Maybe let's even, I mean, you probably get a more exact answer, so let's do cosine just to show you that. So to find y, we can now do the cosine of 21, and so ka, a over h, so y over 22. So I would say if the variable is in the numerator, I actually think maybe trig is a little faster than Pythagorean theorem, and there's not as much rounding. So y is 20.5-ish, 20.54. Now, in example 7, we have to find the missing side first. And in order to do that, we can't use trig. We don't know any angle. So if we don't know an angle, we're going to have to use Pythagorean theorem. So we're going to do a squared plus b squared equals c squared for this. So here's my c. So 8 squared plus 14 squared will equal c squared. So I get like 260 for my c squared. Take the square root. And I got like 16.1 for c. Some of you guys I saw like worked ahead on this and wrote it as a simplified radical, and that's fine as well. So it'd be like 2 square roots of 65, not a very nice number. So if this is 16.1, they want sine of A and cosine of A, so they're just asking you to set up this ratio. So sine of A will equal 14 over 16.1, opposite over hypotenuse. And then cosine of A is adjacent over hypotenuse, so 8 over 16.1. Now this is kind of leading us into what we're going to be doing for tomorrow. So just kind of getting used to setting up the ratio that way. Because tomorrow we're actually going to learn how to find out what that angle is. So if we have that information, we're going to be able to solve for that angle. All right, let's finish up with this last word problem. So it says you want to build a skateboard ramp with a ramp height or ramp length of 14 feet and an angle of elevation of 26 degrees. So again, like I said, trig can apply maybe. I don't know. I remember one of my students once in college called me to tell me she was using trig because she is an occupational therapist and she had to go check around campus. This was one of her projects that she had to make sure all the wheelchair ramps around campus were the right angle of elevation, because if a wheelchair ramp's too steep, that's not very good for someone who has a handicap. So she was having to go and measure and figure out the angle of elevation. And the angle of elevation is exactly what it sounds like. It's how high up something goes. So we have our ramp here. So we're building a skateboard ramp. Hopefully your ramp would look something like that. Otherwise, I don't know what kind of ramp you're using. The angle of elevation is how high up that angle goes. So 26 degrees is the angle of elevation for this skateboard ramp. I don't know what the angle of elevation is for that. Like I said, for that, to be ADA compliant, it's 12 degrees. So yeah, so to make sure that's safe, yeah, it's probably something you needed to know for your degree too. So, so yeah, that's a really important thing because again, you can only expect someone to be able to roll up such a steep grade. So this is 26 degrees. It says the ramp length is 14 feet. So when I'm thinking about the ramp length, that's the part I would ride. So this would be 14 feet. They want the base and height of the ramp. So the base would be down here. And then the height would be here. So I'm going to call that my X and Y. So once you take all the words out of it, this just becomes a trig problem, where we're just trying to find the X and Y for this triangle that is maybe a ramp, whatever it happens to be, that we're trying to find that information. What trig ratio do you guys want to use? Again, there's probably just one you don't want to use. Which one do you guys want to use? Sine, sure. So sine of 26 degrees. And this is my opposite. This is my hypotenuse. So sine is O over H. So X over 14 will give me the height of our ramp. So this is 6.1 feet. So the ramp goes up to 6.1 feet. And then again, you could either use Pythagorean theorem or you could just use cosine. So cosine of 26, because this is the adjacent side, is y over 14. So I do the exact same math, just putting that 14 in place, or the cosine instead. So this is 12.6 feet. So that's how long the base would be by the height. All right, so homework is listed here for you guys. Using all those different trig ratios, make sure you guys bring a calculator home so you have it for homework if you don't get it done now. Again, we're going to do a test on Tuesday.